Hello and welcome to Morehouse's Math Menagerie, where outliers are always welcome. Today, we're going to talk about a T procedure for a sample size that is small. A rare congenital disease, Everleigh's syndrome, generally causes a reduction in concentration of blood sodium. This is thought to provide a useful diagnosis sign as well as a clue to the efficacy of treatment. Little is known about this subject, but the director of a dermatological department in a London teaching hospital is known to be interested in the disease and has seen more cases than anyone else. Even so, he has seen only 18. The patients were all aged between 20 and 44 years old. The blood sodium concentration of these 18 cases are given below. What is the 95% confidence interval for the mean of sodium concentration? Well, we're going to start this process by defining our parameter. We're going to say let mu equal the mean concentration of blood sodium. Our procedure is a one sample T interval for mu. Then we would check our conditions. We have a sample of 18 patients. Note here that this is not a random sample, but since only these 18 patients seem to exist, they encompass the entirety of the population itself. So the random sampling isn't as important here. The 10% condition is met. 10 times n would be 10 times 18, which is 180. And if there are 18 patients in the UK, it's safe to assume there's more than 180 in the entire world. Now, for normality, we're in a little bit of a pickle. It didn't tell us if the sodium concentrations were normally distributed, and we don't have enough patients to claim that the central limit theorem applies. So what we're going to do here is we're going to make a box plot in Desmos of the data. You can see the box plot here isn't perfectly symmetric, but it looks pretty decent. So we would draw this box plot on our paper and we would say that the sample data does not show any major skewness or outliers, so a T procedure is appropriate. Here, we're making an assumption that if the sample looks pretty good, then the sampling distribution is probably approximately normal. This is a very big assumption. Let me show you how I made the box plot in Desmos. I first created a table and typed in the blood sodium concentrations for all 18 patients. Then below that, I typed in box plot and then in parentheses put in x sub 1 to bring up the variable x sub 1 where my data is at, and that gave me this box plot. Now, I did have to change my viewing window to find the box plot, so just be aware that the window will not automatically change to the box plot when you build it. Now, let's go ahead and run, while we're in here, our t-test. So we're going to go to inference, we're going to go to t-test, and we're going to put in our data x1 here as our single sample. I then can hit create test. I will drop down my confidence interval menu. You can see that it's already set to 95%, and it shows that we're between 110.9 to 120.2 would be our 95% confidence interval. To complete our problem, we would then give our conclusion that we are 95% confident that mu equals the mean concentration of blood sodium is in the interval 110.87 to 120.24. Thank you for joining us. I will leave you with this quote by Carl Jung. Have a great day.